potential. So the electrode where oxidation takes place generally at anode, that is your oxidation potential, and at cathode, which is on the right hand side, is your reduction taking place. So that is your uh, reduction potential, right? So does anyone have any doubt in the previous from the previous topic?
No, sir.
Hmm, that's good. Okay. The right topic, factors on which electrode potential depends. Factors on which electrode potential depends. So the first factor on which it depends, nature of metal and its ions. It depends upon the nature of metal and its ions. Like see, zinc is the metal which has ions Zn+2. Whereas if you are going for another metal, you can see Fe is metal and which goes into either Fe+2 and Fe+3. So it depends upon the electrode potential depends upon the its ions or its metal. Basically, metal. This ions comes from the metal. Generally, some D block elements or almost all the D block elements have variable oxidation state. You can see in this iron is showing +2 oxidation state, and in the below it is showing +3 oxidation state. So due to this variable oxidation state, they will have different electrode potential. Are you getting my point, all of you, both of you?
Yes, sir.
The next dependence is concentration of ions. Concentration of ion. Let's say if you the concentration of ions. You know, concentration, we are talking about the molarity. If it will be more, then we will see how it affects the electrode potential in Nernst equation. Basically, what will be the effect if Fe+2 iron is converting into Fe+2 or Fe+3? How it affects when the concentration of iron increases or decreases, that we will all study the variation of this in Nernst equation of in the next lecture. And the third one is temperature. So basically, all I want to say is that this is the three factor on which electrode potential depends. And what will be the effect of all these three or one of them, that we will study in Nernst equation. Got my point? Yeah, let me know when you are done with this.
Done, sir.
Oh, very good. Now, there will be a term that is always used, that is your standard condition. A standard condition. If you have heard about NTP, normal temperature pressure, STP, standard temperature pressure. So in this chapter, we deal with the standard condition, or we also say a standard electrode potential. A standard electrode potential. So basically, electrode potential at a standard condition. What is this under standard condition? In a standard in a standard condition, we consider or we take concentration as concentration will be 1 molarity. Concentration will be 1 molarity. M stand for molarity. The second condition is your pressure in gas, and the pressure should be either 1 atm or 1 bar. And the third, temperature should be either 298 Kelvin, and if you are going to convert it into degree centigrade, it will be this 25 degree centigrade. So this is the a standard condition. Please do write it.
Done, sir.
Very good. So this is the standard condition, and we will talk about this standard condition in Nernst equation basically. Now we are going for again electrode potential. That is our main topic. So electrode potential, as you know, this is of two types: oxidation potential or reduction potential. So you know, in oxidation potential, the metal will have tendency to oxidize itself like this. This M loses n electron and it forms M plus N plus N. N is the number of electron. N is the number of electron. Now, if you want to write E naught, whenever, see this standard electrode potential, we represent this with E. E is the electrode potential, and if I'm going to put naught here, then it will be a standard electrode potential. So I hope it's clear to you. Now see, so E naught, and what happens here? M is converting itself into M plus N. This is the representation which is very important. The question generally arises in this form, not in the chemical reaction form. So you have to understand that E naught M slash M plus N. That means M is going from M to M plus N. This is your oxidation potential. Wait a minute, just don't write not here. It is your oxidation potential. Now, if I'm gonna write here E naught M slash M plus N, then it will be a standard oxidation potential. A standard oxidation potential. What is the difference between oxidation potential and a standard oxidation potential? So the difference is very simple. A standard oxidation potential, in this, the concentration will be 1 molarity, the temperature will be 298 Kelvin or 25 degrees centigrade, and the pressure will be 1 bar and 180. When we talk about oxidation potential, then it is general, like at any concentration, any temperature and pressure. But when you talk about E naught, that means a standard oxidation potential that represents the concentration will be 1 m, the pressure will be either 1 bar or 180 m. It is almost equal, so that's why we take 1 and the temperature either will be 298 Kelvin or 25 degrees centigrade. Is that clear to both of you?
Yes, sir.
Please do write it. Let me know when you are done with this. And write faster, please.
Done, sir.
Very good. Now, after oxidation, in the cell, reduction also takes place. So for reduction, what will happen? A metal has tendency to reduce itself. So I'm going to take M plus N ion that gains an electron and convert itself into M. Convert itself into M. Now the most important point here is that we can go for again E. But here you can see the metal is going from plus N to vitamin. Just wait a minute. Okay, so the metal is going from plus N to M, and this will be equal to, that what is this? This is your reduction potential. This is your reduction potential. And generally, in this chapter, we represent this with RP and oxidation potential with OP. Now, the next is if you are going to put not here, then this will be your standard reduction potential. Again, if it is a standard, the concentration will be 1 m, the temperature will be 298 Kelvin or 25 degrees centigrade, and pressure will be 180 m or 1 bar. So it's very simple. Are you done with this?
Yes, sir.
Okay, Austin.
Yes, sir.
Okay. Now see, you saw that electrode potential is of two types. Electrode potential is of two types. The first one we have studied is your oxidation potential, and the second one that we studied is your reduction potential. You can go for a standard oxidation potential and a standard reduction potential, but both are oxidation potential and reduction potential. Now, if in the question asked calculate electrode potential, so which value we are going to write? Since we have two options, the first one is your oxidation potential and the second one is your reduction potential. So according to IUPAC, always remember this, according to IUPAC, the electrode potential is equal to reduction potential. Are you getting my point? Yes or no? Whenever they say calculate electrode potential, you need to calculate the reduction potential. Are you getting my point?
Yes,
So
sir.
could you repeat that again? I
Yes.
didn't get it.
See, Austin, you have the both potential, oxidation potential and reduction potential. Okay, both
Yes, sir.
oxidation potential and reduction potential. If examiner will ask directly what is the oxidation potential, you can directly go for oxidation potential, and you for reduction potential you can directly go for reduction potential. But what if examiner will ask what is electrode potential? So basically electrode potential is equal to reduction potential.
Oh, yes. Got it.
Let's say we make a rule. If I'm telling you students, under this boys and girls both comes, right? Any gender, yes or no?
Yes, sir.
But if I make a rule, that means a student means, whenever I say student, that means girls. It's just like that. Are you getting my point?
Yes, sir. Yes, sir.
So this is the scenario. Now what I'm gonna ask you is a very simple question. Let's say this is what. Let me know. On the left hand side, it is anode or cathode. This is your anode or cathode.
Annual.
Anode.
This is your anode and this is your cathode, and you know that on the left hand side oxidation takes place and on the right hand side reduction takes place, right?
Yes, sir.
So you know what, if reduction is taking place here, that means m plus n gains n electron and reduces itself into m, and it will have reduction potential that will be equal to, let's say, x. Are you getting my point?
Yes, sir.
Now the next question is very important, please be focused. If you can see, m plus n is getting n electron. This n electron from where? If you remember, this n electron comes from this anode, yes or no?
Yes, sir.
Yes.
Now you know that this is oxidation. So basically, m is converting itself into m plus n electron. Yeah, are you getting my point, Humam? M is converting into M plus N. This is a general equation I'm taking. If you want to go for zinc, you know that zinc will be converting into Zn plus 2 and 2 electron will be lost. And if you are going for zinc here, you know that Zn plus 2 will gain 2 electron and convert itself into Z. Are you getting my point? Zn.
Yes, sir.
Now, what I want to say is that look at this. If it has a reduction potential x, if it gains 2 electron. See, if it gains 2 electron and it has reduction potential x, and in the same way, if you are going at anode, it loses 2 electron, just opposite. You can see here it gained 2 electron and has electrode potential x, and here it loses 2 electrons, so it will have oxidation potential minus X. Yes or no?
Yes.
Umam?
Yes, sir.
So it's very simple. All I want to say is that this electrode potential, the electrode potential will always be equal to a reduction potential, and oxidation potential will be negative of reduction potential, because you know that in oxidation potential, let's say if oxidation potential is given, the number of electron lost by one at one of the electrode will be gained by metal on cathode or one of the electrode. Yes or no?
Yes, sir.
So please do write this point OP, RP. This point is important. Then I'm gonna earn this point as well. Don't write all. I just needed to prove that this reduction potential and oxidation potential are numerically equal, but they are opposite in sign. Let me know when you are done with this.
Done, sir.
Very good. Now see, we are going to derive a formula for this electrode potential. So always remember that. Again, I'm going to write these points, which is very important. Electrode potential, that will be equal to reduction potential. A standard electrode potential will be equal to a standard reduction potential. OP, that means oxidation potential. Just wait a minute. A standard reduction potential, oh sorry, OP Oxidation potential will be equal to minus of reduction potential. A standard oxidation potential will be equal to this. Please do write it. Just write it. Done, yes or no?
Yes.
Okay. Now see, we are going to derive the formula for EMF of cell. So you know that there is a container on the left hand side, whatever it is, that is your anode. And on the right hand side, it will be your cathode. Now they are connected with a potentiometer like this. And also, you know, this is your anode and this is your cathode. Now see what will happen. You know, on the left hand side, oxidation will happen. On the right hand side, the reduction will happen. M is converting itself into M plus N electron, and M plus N will gain N electron and convert itself into M. Now what you need to do is very simple. If you are going to calculate EMF or electrode potential of cell, you need to add all the potential. That means electrode potential of oxidation potential and reduction potential. Are you getting my point? Yes or no?
Yes, sir.
And
Yes.
this oxidation potential is for anode and this reduction potential is for cathode. Are you getting my point? Since the reduction potential directly occurring on the right hand side and oxidation potential directly occurring on the left hand side, and if you remember this EMF is, we are talking about E, electrode potential. So we have to change this oxidation potential into reduction potential. Are you getting my point? When we talk about E, just write it first, then I will tell you. Let me know when you are done writing with this. Austin or Mahmoudin?
Yes, sir, done.
Done? Okay. Now
So
see what I want. Yes.
So what does EMF mean? Like what's the full form?
EMF is electrode potential. Basically, you have studied this about in cell in current electricity. Have you studied this chapter, current electricity? Yes or no?
Yes, so we just started actually.
So EMF you will study, that is electromotive force. Basically, that is your potential present in cell or batteries. Got it?
Yes, sir.
So that is same electrode potential. That's why I wrote here E. E, that is electrode potential. Okay. So as I said that electrode potential is equal to reduction potential, but if you are going to see here, I have written the value of oxidation potential, yes or no?
Yes.
So we have to change this because electrode potential will be only equal to reduction potential, not oxidation potential. So if you are going to change oxidation potential into reduction potential for this, what you need to do, it's very simple. You are going to write negative because they are equal. This, see, this is very important to note, and generally students do mistakes here. What I want to, the derivation is not important. Only the formula is important. What I want to tell you is that E cell is equal to minus E anode of reduction potential. Let me just arrange it. E cathode minus E anode. You know that at cathode, generally, a reduction takes place. So in questions, the reduction potential at cathode will be given. But when you are going to talk about anode, at anode, oxidation happens or oxidation occurs. So there will be either oxidation potential given or there will be either reduction potential given. But you have to write the value of reduction potential for both, whether it is at cathode or anode, to calculate E cell. And we can also modify this formula. E cell is equal to E right minus E left. Don't use the oxidation potential, convert that into a reduction potential. Are you getting my point?
Yes.
Yes.
Very good, thank you. And a standard reduction potential you can also calculate, that will be given. I will give some example first, right? Just wait a minute, it will be. Always remember that this will be for reduction potential as well as this will be for reduction potential. R for right, you know, right is for cathode, L is for left, left is for anode. Are you done with this?
Done, sir.
Now see. Just wait a minute. There will be Test at 8 p.m. today of yours. That's okay. Also, E naught I already told you. E naught cell will be equal to E naught cathode minus E naught anode. And this is for SRP, standard reduction potential. This is also SRP. Anode at anode oxidation takes place, but we need to calculate the reduction. What you need to do, if oxidation potential is given, just change the sign and you will get it. Let's take an example question. Ni slash Ni plus 2 double slash, let's say molarity is also given, the concentration is also given, Ag plus 1 slash 1m, no slash, this is 1 slash Ag. It is also given in the question that E naught, this is your E naught, Ni plus 2 slash Ni is equal to minus 0.25 volt, and E naught Ag plus slash Ag, that is equal to 0.80 volt. Calculate E naught cell. Since a standard is given, so they will ask you a standard cell potential. Will you be able to solve this? What you have written, Austin 1?
So 1.05.
Okay. How many answers? Okay,
No, sir.
Mom, just concentrate here. If you remember the formula, you can do this. Calculate E naught cell. E naught cell has a formula. Either you can write E naught right minus E naught left, or either you can write E naught cathode minus E naught anode. Okay, this was the formula, Mom.
Okay.
Now you can see this is on the right hand side, which is cathode, and this is on the left hand side, which is anode. And we have learned about this when we learned the representation of cell. Yes or no? You know that from this representation, on the right hand side it is cathode, and on the left hand side it is anode, right?
Yes, sir.
Now you can see right hand side is what? Right hand side is Ag, right? Now you need to check whether this potential, a standard potential, is given a standard potential is a reduction potential or oxidation potential. So you can see it is going from +1 to 0, +1 to 0. So it is reduction potential. Yes or no? So you can
Yes, sir.
directly write 0.80. You don't need to change the sign. And if you are going for the left on, you can see nickel is given, and you can see this is also going from +2 to 0. That means the reduction potential is directly given, so you don't need to change anything. And minus 0.250. If you are going to solve it, you will be getting plus 0.25, and then E naught cell will be equal to plus 1.05 volt. So this is the value of E naught cell. Is that clear?
Yes, sir.
Can I change the slide?
Yes, sir.
Okay. So I'm gonna give you two questions, and Zn slash Zn plus 2 double slash Cu plus 2 slash Cu, and it is given that E naught Zn plus 2 slash Zn, that is equal to minus 0.76 volt, and E naught Cu plus 2 slash Cu, that will be equal to plus 0.34 volt. Find E naught cell. There is another question on the same. Zn slash Zn plus 2 double slash Pb plus 2 slash Pb, and it is given that E naught Zn slash Zn plus 2 0.76 volt, and E naught Pb plus 2 slash Pb minus 0.13 volt. Find or calculate. Please do solve it. I'll be back. Oh, very good, Austin. Just wait for a few minutes. I'll be back. Am I audible? Sorry, I was. Whose answer is this? Oh, Mohammedan, yours. Austin, are you there?
Yes, sir.
So, Austin, what is the answer for the second one?
I'm not sure, so maybe 0.63.
0.63.
Yeah.
Yeah, it is.
Uh,
Humam, your first question answer is correct. You know that E naught cell will be equal to E naught right minus E naught left, or E naught cathode minus E naught anode. For right, you can see Cu plus 2 Cu, and it is also reduction potential given. So plus 0.34 minus left, and here you have to check again and again whenever you are going to solve the question whether this potential is oxidation or reduction. If it is oxidation, then you need to change it in reduction. So after solving it, the answer that you will get is 1.10 volt. Now come to this point, E naught cell is equal to E naught right minus E naught left, right? Now you can see that E naught right, PV plus 2 slash PV. And here a reduction potential is given. So you can write the value as it is. Now on the left hand side, it is zinc. And here the value is 0 to plus 2. That means this is your standard oxidation potential value given. If you want to know the reduction potential, you need to change the value, sign of the value. So the value will be 0.76. Mom, are you getting my point?
Yes, sir.
And hence it will be minus 0. Or sorry, plus 0.63.
Sir, I didn't get it. Sorry.
Okay.
Happy one.
So, Humam, one thing you know, that is E naught cell is equal to E naught right minus E naught left. Yes or no?
Yes, sir.
What this is for right. So you know that this is we are going to put the value of lead. Yes or no?
Yes.
The main important point, the value should be for reduction potential. Now how you are going to recognize whether it is reduction or not? So PB plus 2 is going into 0. So this is reduction. That means this is your reduction potential value given. This is the value of reduction potential. Are you getting my point?
Yes.
Now, when you are going on the left hand side, this is your zinc. And for this, you are going to see you have a value this. But what is the value of this? What is it? Reduction potential or oxidation potential? So you can see from 0 to plus 2. From 0 to plus 2. That means this is oxidation taking place. Yes or no?
Yes.
So this is the value of oxidation potential, and since not is there, that means this is the value of standard oxidation potential. And as I told you, in this formula, we put only the value of reduction potential. So how you will get, if a standard oxidation potential is plus 0.76 volt, then the standard reduction potential of this is minus 0.76.
Okay, sir.
So it's very easy. Let me know when you are done with this.
Yeah, done, sir.
Very good. Just wait a minute. So The next topic. Now you can easily calculate the value of E naught cell or E cell, right? The next topic is feasibility. Feasibility, that means a spontaneity of cell and gives free energy. Feasibility or spontaneity, that means a cell which works on its own. It doesn't require any external agent. Are you getting my point?
So could you repeat that?
See, feasibility or spontaneity, that means a cell that works on its own. It doesn't require any external agent like temperature, pressure, and all.
Yes.
Let's say if you have a ball here, and if you want to move this ball upward, you need external agent. Yes or no? Both of you
Yes.
need to push it. But if the ball reaches here, does it need any external agent? It will go on its own. So from this point to this point, it will be a spontaneous, and from this point to this point, it will be non-spontaneous. Are you getting my point?
Yes, sir.
Now, in chemistry, in physical chemistry, we deal with the spontaneity with the term that is gives free energy, and whenever the value of delta G less than 0 gives free energy value in negative, that means it is feasible or the cell is spontaneous. It will work on its own. It doesn't require any external agent. Are you getting my point?
Yes, sir.
Yes.
So we have a formula from thermodynamics. Delta G is equal to minus NF E naught cell. Now, if there is any question whether the cell is feasible or not, you can easily apply this formula and get your answer. How you will get your answer? N is the number of electron transferred. That means you are going to write the equation and you can see how many electron gained or lost. Either you can take all the gained or either you can take all the lost electrons. Are you getting my point?
Yes, sir.
Yes.
F is Faraday's constant, which has a value 96,500 coulomb. E naught cell, you know that this is your standard electrode potential, and you can calculate this in the same way that we did some questions. And if it is given directly, that is well and good. And delta G, you know that delta G will be gives energy, gives energy. Is that clear? Now please do write it. Are you done with this?
Yes, sir, done.
Okay, now see, delta G should be negative for spontaneity. So you know that this n is number which will be positive always. F is also number, you can see 96,500 coulomb, which is a scalar quantity. This will always be positive. Now, if this will be positive, if E naught cell, always remember that if E naught cell greater than 0, if E naught cell greater than 0, then this delta G naught after multiplying by this formula will be lesser than 0, and hence the cell will be feasible. Are you getting my point? Because this is positive, this is positive, and this is positive, then these all are positive multiplying into negative and becomes negative. But if E naught cell, let me, if E naught cell greater less than 0, less than 0, let me check the sign of this E naught. Okay, E naught cell less than 0, then what will happen? You know, delta G will be equal to minus NF E naught cell. And you can see this is your positive, this is your positive, and this is your negative. If this will be negative, this will be multiplied with the formula negative of the formula, and delta G becomes greater than 0, and hence it will be not feasible or non-spontaneous. What I want to say is that if in the question it has been asked whether the cell is feasible or not, if it is not asked, if the examiner has not been asked the has not asked the value of delta G, if it only asks you to tell that whether the cell is feasible or not, then what you need to do, calculate the value of E naught cell. If E naught cell is positive, then it is feasible. If E naught cell is negative, then it is not feasible, because if it is negative, it the value of delta G becomes greater than 0. Is that clear?
Yes,
Yes,
sir.
sir.
And also please write, since E naught cell we took here, please do write delta G naught. A standard gives free energy. So I'm gonna just give you a question, and then ma'am will join soon. Find a standard gives free energy and predict the feasibility of cell. And the cell is Zn slash Zn plus 2 double slash Cu plus 2 slash Cu. E naught Zn plus 2 slash Zn is given as minus 0.76 volt, and E naught Cu plus 2 slash Cu is given as plus 0.34 volt. So, please do it. And the answer will be in Joule.
Yes.
Yes, sir.
Okay. There. So this is it. I'll be seeing you in the next class. And in the next class, we are going to start nose equation, which is very, very important. Okay. Please wait for me. Thank you.